Let's find the inverse Z transform when the numerator power and denominator power are almost same, or if numerator's power is larger than that of the denominator. Let's see this problem. Here the numerator power m is equal to 2 and denominator's power n is equal to 2. When m and n are equal, then we don't satisfy the terminology, that is m less than equal to less than n. If m is less than n, then directly we can solve it by means of partial fraction method. If m is greater than or equal to n, then we have to go for division. Let's see how we need to go for this division. So here we get this one as it is. So we have to divide the numerator by denominator. So let's write it in this fashion. It is z raised to minus 2 plus 2 into z raised to minus 1 plus 1, we'll write as it is, and then we divide it by means of this. So we write it in this fashion. It is 1 by 2 z raised to minus 2, this term minus 3 by 2 z raised to minus 1 plus 1. So when we go for this division, then to make this we have to cancel out this z raised to minus 2 from the numerator, then only we can make it, that is the m less than n. So we have to get it to the form m less than n. So our aim is to cancel this z raised to minus 2 from the numerator. So for that, let's multiply this equation with 2 and apply over here. So 1 by 2 into 2 is nothing but z raised to minus 2 we get. It is minus 3 z raised to minus 1, and this becomes simply plus 2. And when we go for subtraction, we change up the signs. So this cancels and we have 2 plus 3 as 5. So it is 5 z raised to minus 1 and it is minus 1. So this is our x of z. Now we write our x of z in this form. X of z is equal to, so this x of z can be now when we look at this remainder is having z to the power minus 1. When remainder's z raised power is less than that of the denominator, we can stop our division. So this x of z can be written as this 2 plus, now our new numerator becomes 5 into z raised to minus 1 minus 1, this one divided by, so this same, it is 1 minus 3 by 2 into z raised to minus 1 plus 1 by 2 into z raised to minus 2. So when we do this, now we can go for partial fraction method for this, and it is same as the previous problem. So directly we write this one as it is 2 plus, let's write k1 or a divided by, let's write k1 divided by. So we have to factorize this one. The factorization of this will give 1 minus 1 by 2 as in the previous problem, 1 minus 1 by 2, and even we have seen how to obtain these. 1 minus 1 by 2 z raised to minus 1, and another one is 1 minus z raised to minus 1. So we can write k1 divided by 1 minus 1 by 2 z raised to minus 1 and plus k2 divided by, because two roots are there, k2 divided by 1 minus z raised to minus 1. The next point is we need to go for finding. So we have to consider this as a single term and we should go for finding its factors. We consider this one as x1 of z, and just by considering this x1 of z, by treating only this much, we go for finding the constants. So if we find the constants of x1 of z in this way, x1 of z is nothing but 1, or we can write it as minus 1 plus 5 z raised to minus 1 divided by 1 minus 1 by 2 into z raised to minus 1, and other one is 1 minus z raised to minus 1. So we find the constants of this, wherein this k1 and k2 we can write. So k1 divided by this first root 1 minus 1 by 2 z raised to minus 1, and other one is k2 divided by 1 minus z raised to minus 1. So the values of k1 and k2 are already obtained. So straight away let's substitute it here, because in the last problem we have obtained the value of k1 is, so by solving this we got k1 as minus 9 and k2 is equal to 8. So let's use those and write it here. So the value of our x of z is given by, let's write x of z. This x of z is equal to, from this it is 2 plus, and from this equation the values of k1 and k2 are minus 9 and 8. So minus 9, 8 divided by 1 minus z raised to minus 1. So to find the inverse Z transform of this one, we need to know its ROC. So ROC is Z greater than 1. So Z is greater than 1 means we have the ROC of this problem wherein the ROC lies outside of the circle with radius 1. So we have the two roots 1 by 2 and 1, and ROC is outside of that 1 by 2 as well as 1, so both are right-handed sequences. Even this is right-handed and the first one is also right-handed because it is 1 by 2. So for right-handed sequences, so we need to just write this one as 2, and instead of writing this as 2 we can write del of n with this and plus, sorry, it has to be minus, so minus 9 as it is, and 1 divided by 1 minus 1 by 2 z raised to minus 1, inverse Z transform has to be. So when we have 1 by 2 raised to n into u of n, we will get its Z transform as 1 divided by 1 minus 1 by 2 z raised to minus 1. So it is minus 9 into half raised to n u of n. Now plus, it is 8 into u of n. So this is the inverse Z transform when we have our m greater than n. When m is greater than n, how to solve the problem. So we have seen, and similarly we can work on the different problems. Now the next thing is finding the inverse Z transform when by using the power series or Taylor series expansion method. Let's see how this happens. X of Z is equal to 1 divided by 1 plus 1 by 2 Z raised to minus 1, where the magnitude of Z is greater than half. And the other problem is same, 1 divided by 1 by 2 it is. 1 by 2 only it is, where Z is less than 1 by 2. Then let's see how to solve these problems. Now when we have this X of Z, that is 1 divided by 1 plus 1 by 2, when Z is greater than 1 by 2 is given to us. Then in doing the solution of that, what we have to do is, in solving the A, so we are given with 1 divided by 1 plus 1 by 2 into Z raised to minus 1. So in solving this, we are given with this condition. So we have to go for continuous division here. In the power series expansion, we have to divide the numerator by denominator, and the generated value will be the right-handed sequence, because Z is greater than 1 by 2. So we'll be generating the right-handed sequences. As we are generating the right-handed sequences, means we'll be having the negative powers, because for right-handed sequence we have the Z transform expansion. Let's write it is n is equal to minus infinity to plus infinity. X of Z is equal to x of n into Z raised to minus n. And if it is right-handed, now when we expand this, we go on getting the terms like starting from when x is equal to, like when n is minus infinity, so x of minus infinity, Z raised to minus of minus infinity, which will make it as the positive infinity, that is plus infinity, and so on. We get many the terms, and let's say when Z is equal to, when n is equal to minus 1, it is x of minus 1 Z raised to minus of minus is nothing but plus 1, and we get x of 0 into Z raised to 0. So let's write x of 0 here. Let's write x of 0 plus or Z to the power 0, and then we go on to the positive values of n. Now n is taking the positive values. When n is 1, we can write it as x of 1 Z raised to minus 1 plus x of 2 Z raised to minus 2. We can write Z raised to minus 2, and so on. We can write at last x of infinity plus infinity raised to Z raised to minus infinity. So if we are given with Z greater than 1 by 2, means it is a right-handed sequence. So we'll be generating these terms starting from, like, it may be a constant, then Z to the power minus 1, Z to the power minus 2, and so on. And if it is, on the other hand, a left-handed sequence, then for Z is less than 1 by 2, so we'll be generating Z to the power plus 1, plus 2, and so on. It may run up to the higher values. So the thing is, to generate the positive values of Z or negative values of Z, we have to decide upon, and we have to align our denominator in that fashion. So here we are having Z greater than 1 by 2, so we need to write it in this fashion. So 1 plus 1 by 2 Z raised to minus 1. So, and the next thing is 1. So let's multiply this with 1 and subtract from here. So we get 1 plus 1 by 2 z raised to minus 1. So when we subtract from here, we get, when we subtract, so 1 minus 1 is a 0, we get minus of 1 divided by 2 into z raised to minus 1 here. Now as remainder is, as we have 1 by 2 z raised to minus 1 here, so to cancel it out, we need to multiply here the first term, which is 1, with 1 by 2 z raised to minus 1. When we multiply this one by 1 by 2 z raised to minus 1, then it would be 1 by 2 z raised to minus 1. But when we take it to the positive power, when we take this one as plus, then what happens? So this term will not get cancelled. This term will not get cancelled. So we should get minus 1 by 2, so that when we change the sign, it gets cancelled. So minus of 1 by 2 into z raised to minus 1. And again when we multiply this one, we get this one as, so minus 1 by 2 into minus 1 by 2, which is minus 1 by 4 into z raised to minus 1 into minus 1 z raised to minus 2 it is. Again when we go for change of sign, so this becomes plus and this one is again plus. So it cancels and we get 1 by 4 into z raised to minus 2. And we can continue up to 4-5 steps to cancel it out, because again the next term is to cancel this. Means we have to take the next term as, so we should get again plus. So the term has to be plus 1 by 4 into z to the power minus 2. When we multiply this one, we get 1 by 4 z to the power minus 2. And this 1 by 4 into this 2, it is plus 1 by 8 divided by 1 by 8 into z raised to minus 3. So it continues. So let's see how does the system. So in this fashion, 1 plus 1 by 2, similarly it is being continued, and we go on getting 1 minus 1 by 2 z raised to minus 1 plus 1 by 4 z raised to minus 2 minus 1 by 8 z raised to minus 3, and so on. Then we can write whatever, and x of z is nothing but whatever we get the result of this division. So whatever, we may go up to 4-5 steps and we'll write this as it is. So 1 minus 1 by 2 z raised to minus 1, and so on. And we compare this one with, we compare this result with these values. So x of 0 we can consider as, so our x of n is nothing but, we can compare, so this we consider as our x of z, and this x of z is equal to this value. If the x of z is equal to this, so x of n is equal to, now it is first, we need to convert, so it is x of 0's value, so which is 1. It is 1. So x of 0 is 1. So let's put these values in this fashion. X of 0 is 2. Now x of 1 into z raised to minus 1. So what is its value? So when we take the z transform of what value, we'll get z raised to minus 1. So it is del of n minus 1. When we take del of this, x of 1's value is minus of 1 by 2. So let's write minus of 1 by 2, and it is multiplied with z raised to minus 1. so which is nothing but del of n minus 1. X of 2 is plus 1 by 4, so just we need to write in this fashion, and del of it would be n minus 2. So in this fashion it continues, del of n minus 2, it continues. So this is the way we need to solve this problem. Then let's see how to solve the other one when ROC is z is less than 1 by 2. So when z is less than 1 by 2 also, the process remains the same. The process remains the same, that is division. So we have to divide the numerator by denominator, but in this case as z is less than 1 by 2 means we have to generate the positive powers of this result. So it would be 1, let's write 1 divided by, in this fashion, 1, and to generate the positive powers of our result we don't have to write it in this fashion, so let's write it as 1 by 2 into z raised to minus 1 plus 1, and we always think that how can we cancel this. Now how to make this one as 1? When we multiply, now when we take 2 into z, when we multiply this first term with 2 into z, we can make this first term as 1. So that is the way. So when 1 by 2 into z raised to minus 1 gets multiplied with 2z, then we get the first term as 1 and the second term will be plus 2z. So when we change the signs, we can cancel out these terms. So this cancels, we get minus 2z as the result. Now our next aim is how can we cancel this term. So with what I can multiply so that minus 2z I can generate here. So minus of, let's say, 4z square. When we take minus of 4z square, then what happens? We get 2 into z raised to minus 1 into z square will give, this will give us 2z. So plus, this 1 into again minus 4z square we get. We'll change the signs, let it be, so minus of minus, so already this is minus, it has to go because this is minus sign, so minus 2z it is. So let's make this one as plus and cancel, and we get a plus here, plus 4z square. Then the next aim is again how can we cancel this plus 4z square, which has to be, now we have to take a positive value which will be 8 into z. So in this way it continues and we can go for 4-5 steps and we'll write the result. Now this is nothing but our x of z. Instead of rewriting, let me write it here. The x of z is equal to this much. So here as we see z to the power 1, if it is, then it is the value of z raised to minus 1. So it is z raised to minus 2, minus 3 and so on. So our x of n is equal to, it has to be 2 into z raised to 2 into z minus 4. So we need to write this one as 2 into del of n plus 1 minus 4 del of n plus 2 plus 8 del of n plus 3 and so on. So we can put dash dash and this would be the solution. So even one can write this first one as, So we have del of n minus 1 by 2 del of n minus 1 plus 1 by 2 del of n minus 2 can be written as it is minus of 1 by 2 raised to n into u of n. Because when n is 0, we get simply 1. When n is 1, it is 1 by 2 into del of n minus 1. So in this way, we can write. So this is regarding the power series expansion method. So we can solve some other problems in the next video. Thank you.